Hi, welcome to the video tutorial Spring Boot RESTful CRUD API with me Nam Haming from codejava.net. Throughout this video, you will learn how to develop a Spring Boot application that provides RESTful Web Services API for CRUD operations on a MySQL database, create, retrieve, update, and delete, and you will learn how to code the Spring Boot project using Eclipse IDE. This picture helps you understand the Spring Boot application which we will develop throughout this video. You see, our Spring Boot application runs an embedded Tomcat server which hosts a Java web application based on Spring MVC framework, and to expose RESTful web services API to the clients, we use Spring REST controller to provide RESTful web services API for CRUD operations like create, retrieve, update, and delete. And we use Spring Data JPA for the data access layer. Spring Data JPA relies on Hibernate framework to work with a relational database like MySQL database. And the clients consume RESTful Web Service API using standard HTTP methods such as POST for create a resource, WAIT for retrieve operation of resources, put to update a resource, and delete to remove a resource. To follow this tutorial, make sure that you have the following software programs installed on the computer: Java Development Kit version 1.8 or higher, Eclipse IDE, MySQL database server, and CUL program to test RESTful Web Services API. And here are the steps which we need to follow. First, we need to create a MySQL database, and then we create a Maven project and configure dependencies for Spring Boot. And we need to configure data source properties for the database connections. And then we code a domain model class to map with a table in the database. And then we code Spring Data JPA, a repository interface. And then we call a Spring services class, and then we got the Spring Boot application class to run our Spring Boot application. And the most important part is we will record the REST controller class to expose a RESTful CRUD API to the clients. And finally, we test RESTful web services using a CUL program. And this class diagram helps you understand the main Java interfaces and classes which we code throughout this project. We develop RESTful Web Services API for the CRUD operations on product table in the database. So we need to create a domain model class product to map with the table product in the database. And in the data access layer, we declare a repository interface, product repository that extends the JPA repository interface to simplify the data access layer. And in the business service layer, we record the product service class that implements CRUD operations. This save, get, and delete this product services class depends on an instance of product repository. And for the controller layer, to expose a RESTful Web Services API to the clients, we code a Spring REST controller class product controller that exposes web services or RESTful methods list, get, add, update, delete, which correspond to CRUD operations. And this controller class depends on an instance of the product services class. And to run our Spring Boot application, we need to code the main class application. And throughout this video tutorial, we will revisit this class diagram to help you understand how the code we write. Now let's create a MySQL database. This here MySQL workbench on my computer. Now I create a new database or new schema. Enter the schema name is MyDB and click apply. Okay, and you see the new database, new schema was created, MyDB here. And let's create a new table, create table. Enter the table name is product and add some columns. The first column is ID, which is a primary key. So check this option PK, not null, and auto increment. And the second column is name, varchar 45, not null. And the third column is price. Data type is float number here, not null. Okay, and click apply. Finish, and you see we have the product table what created here with 3 columns: ID, name, and price. And in the Spring Boot project, we code RESTful Web Services API to expose API for CRUD operations on this table product. And next, let's create a new Maven project for Spring Boot application. We can use the Spring Initialize tool provided by Spring Community to generate the skeleton code for the project. So go to start.spring.io start.spring.io, and you see this is the user interface of Spring Initialized that allows us to generate project. So we choose Maven project language Java version 2.2, and enter the group ID is net.codejava. Artifact is product REST, and we specify some dependencies for our Spring Boot application. The first is Spring Web. You see, build web including RESTful applications using Spring MVC. So click plus button here. And the second dependency we need to specify is for MySQL JDBC driver. MySQL driver here. And third dependency is for Spring Data JPA. Spring Data JPA. That's it. You see, we have specified three dependencies for our Spring Boot project: Spring Web, MySQL JDBC driver, and Spring Data JPA. And then click the generate button here to generate the code. Generate and download the code to a directory on my computer. Web services. Save. Okay. Open the folder. Yeah. And extract this zip file. Extract here. Okay. And in Eclipse IDE, we import that project. I import project from a folder or archive here. Next, and choose a directory. Web services here. Product REST. Okay, and click finish. Here we go. You see, the project has been imported to Eclipse IDE, and Maven is updating the project configuration, as you can see here. It will take a moment. Okay, you see, Maven automatically downloads all the Java files required for the project, and you can see here there are many Java files required by Spring Boot, Spring Web, Spring Data JPA, MySQL, JDBC driver. And this is a Maven project file. You can see the parent of the project is Spring Boot starter parent here. You can see the dependencies we specify Spring Boot starter. This the JPA Spring Boot starter web. The MySQL connector Java is MySQL JDBC driver, and you can see the dependency for test. We don't need test, so delete this dependency. And you can see the plugin for Spring Boot Maven plugin here. We need only three dependencies: Spring Boot starter data JPA, Spring Boot starter web, and MySQL connector Java. So we need to delete everything from the test folder here. Okay, that's it. We have created Java Maven project for our Spring Boot application. That we name the package to rename net.code Java. Okay. Continue. And you can see Spring initialize to automatically generate code for the main class that starts our Spring Boot application. Here you can see using the Spring Boot application annotation. So we rename this class to just application. Finish. Okay. Next, let's configure data source properties for the database. You can see in the project there's a properties file application.properties here. Open it and specify some properties for database connection. Spring JPA dot Hibernate dot ddl hyphen auto equal none. So Hibernate will not generate database. And the second property is spring dot data source dot URL. This is a JDBC URL that points to our database JDBC colon MySQL colon double / is localhost colon the port number of MySQL server default port number is 3306 / and the name of the database MyDB. You see the database names on my computer is MyDB here. And the third property is for username, which is spring.datasource.username. Username is root, and the last property is password. Password on my computer is password. You need to modify username and password and database URL corresponding to the values on the computer. Okay, save the file. And next, we need to code a Java domain model class to map with the table product in the database. You see in the database we have the table product here, and in Java code we need to create a Java class to map with this table. So in the project we create a new class here. New class, class name is product. Finished. And in this class we declare 3 fields according to 3 columns in the product table. First one is ID. Second field is name. And last field is price of the product. And we generate getter and setters methods for this domain model class. Source generate getter and setters here. Select all and generate. Okay, you see. And we need to generate constructors. Right click here, source, generate constructor using fields here. Select all, generate. And we also need to generate no argument constructor. Source, generate constructor from superclass here. Generate. Okay, and reformat the code. Source, format here. Okay, you see the code has been reformatted. Okay, and to map this domain model class with table with the same name in the database, we use a JPA annotation entity from the package java x.persistent here. Since the class name is same as the table name, we don't need to specify the table name, and all the field names are identical to the names of the columns in the database, so we don't have to specify a mapping for the column name. We just need to specify the primary column for the ID field here. So yeah, use ID annotation. and use a generated value, generated annotation here. Use value, and strategy is identity. So the values of the ID column will be automatically generated by the database. So that's it for the domain model class. So far we have got the application class and product domain model class, and next we need to define to code the product repository interface that extends JPA repository. So Spring Data JPA we generate implementation code for the most common CRUD operations: create, retrieve, update, and delete. So we don't have to write a single SQL query. So the next step is code repository interface. Yeah, create a new interface here. Interface. The name of the interface is product repository. Finish. And this interface extends JPA repository, and we need to specify the type parameter. T is for the domain type, which is product, and ID, which is a type of the ID field, which is integer. So that is very simple. This is a product repository interface. So based on this Spring Data JPA, we generate implementation code. We don't have to write a single SQL query. That's a great benefit provided by Spring Boot. And next, we need to code the service class that acts as the middle layer between the persistent layer, the data access layer, repository, and the controller layer. Now we need to code the product service class. Create new class here. Name of class is product service. Finish. And we use a Spring annotation service. This here, this 12 Spring, this is a service class. And in this service class, we need to have an instance of product repository. So we declare private field here, product repository or repo, and we let the Spring framework inject an instance of product repository. So we use a auto y annotation. Yeah. And in this service class, we implement the CRUD method by delegating all the code to the product repository class. So as you can see here, the methods in the product service class here it lists all save, add, delete. Okay. And the first method is to list all products. List product list all, and we simply return delegate the code to the repository instance here, repo.file. That's it, very simple. And the second method is to create or update a product. Public void set product, and we simply delegate the code to the repository interface here, repo set product. And the next method is to get a particular product based on ID. Public product get integer ID, and we also delegate the code to the repository repo find by ID. And the last method is to delete a specific product based on ID. This find by ID method return optional, so we need to call that to return the value object product. The last method is to delete a specific product based on ID. Simple, we delegate the code, delete by ID. That's it, very simple. And you can see with Spring Boot, coding for the data access layer is very simple. We just declare repository interface, specify the type, domain type, and type of the ID class, and that's it. And this is a Spring service class, and the most important point here is injection, auto while injection of the product repository instance here. So far we have created the product service class. The main application class is generated, and now let's write code for the REST control class to provide RESTful API for CRUD operations. As you can see in the class diagram here, the product controller class with the methods exposing RESTful Web Services API, list, add, update, and delete. So create a new Java class here. The name of the class is product controller. This is Spring REST controller. Finished. And in this controller class, we use a REST controller annotation to tell Spring Framework that this controller we handle requests for RESTful web services, and we need to have an instance of the product service class injected into this controller class. So we use a auto while annotation. Private product service that's it. And then we implement method for the RESTful Web Services API. And the first method is to list all products. So here's the method. We call the method public list product. list, and simply we delegate the code, forward the code to the service list all. And to expose this method, to let this method handle HTTP GET request, we use a GET mapping annotation and specify the URL. Relative URL is products. That's it. Now we can run our Spring Boot application by run the application main class here. Right click, run as Java application. You see, our Spring Boot application is starting, and you can see various login messages, and you can see Tomcat started on port 8080 with context path empty. And that means our Spring Boot application is up and running, and now we can test our first RESTful Web Service API that list all products here. We can use browser because this method requires HTTP GET, and web browser is supporting HTTP GET request. So here we can type the URL HTTP localhost 8080/products, and you can see it returns empty string because we don't have any rows in the product table. And now let's create a new row, insert a new row into the product table. Here, select rows and insert a new row here. Name is iPhone X. Price is 999.99. Okay, and click apply. Finish, and we got one row inserted into this product table. And now let's refresh the browser and you will see. Here we see the server returns JSON representation of the product list, and you can see there's one product here with ID 1, name iPhone X, price 999.99. We can also use a CLL program to test our RESTful Web Services API. Let me open the command prompt in Windows operating system. We can use the CLL command and followed by the URL of the RESTful Web Services API. Localhost 8080 products, and you can see the server response with a JSON representation of the list of product. Now let's try to insert a second row into the table product here. X box and price is 399.88, and click apply. Finish, and run the CL command again. You see there are two products now, ID 1, ID 2. We can refresh the browser here. You can see there are two products represented in the JSON string here. Very good, right? So that we have implemented the first RESTful Web Services API for the retrieval operation, which list all products from the database. And next, let's implement the second RESTful API method that allows the client to get information about a specific product based on product ID in the product controller class here. The second method, public product get. This method also handles HTTP GET request, so we use a GET mapping annotation, and the URL pattern is /products / followed by the ID of the product, and we use the annotation path variable to map the value of the product ID in the URL here as the variable, as the parameter argument of this method, integer ID. And in this method, we simply return service.get ID. Save, and we need to stop and start the application again, because Spring Boot application is a standalone application. Okay, our Spring Boot application is starting. Okay, now we can test using a Chrome browser. This URL returns all the products, and this URL will return the product with ID 1. Hit enter and you will see it returns the product with ID 1. Name iPhone X, price 999.99. And we can try to get information about the product ID 2, and you can see it returns information of product with ID 2. Xbox. Let's try to get information about the product ID 3, and you can see we got an error because there's no such product with ID 3. You can see the error, no value present in the optional object returned by Spring repository class. Here, so we need to modify this method to handle such exception. If the exception occurs, we return HTTP status not found. So we can modify this the return type of this method. Response entity. This method returns a response entity object of type product, and we assign the return value of the red method product and surround with cat statement here. Catch no such element exception. No such element exception. E. And in if the product found no exception thrown, we return a new response entity, including the product information and the HTTP status. Okay, return new response entity of type product and includes product object and HTTP status Okay, yeah. So you see, Spring framework uses JSON transaction library to automatically serialize Java object to JSON. And in case the no product is found, the exception no such element exception is thrown, we return a response with HTTP status not found for. So return new response entity. Response entity product and HTTP status not found, not found 404. Okay, and we need to stop and start the application again. Start. Okay, now we can test using Chrome browser. There's a product with ID 3, and you can see the server now returns HTTP status code 404 here, which means not found. We can test using a CEL program here. Type the command CEL HTTP localhost 8080 products/1, and you can see the server response with information about the product with ID1 iPhone X here, and we can use a V option to see the verbose output, and you can see the server returns HTTP status 200. Okay here, and let's try to get a product with ID doesn't exist in the database, ID 3, and you can see the server returns HTTP status code 404, which means not found here. Okay, so we have done implementing the RESTful web services method for the retrieval operation, which allows the client to get information of a specific product. And next, let's implement the third method add that exposes a RESTful web service API that allows the clients to add a new product, save a product to the database. So we implement a new method here. For this kind of method that creates a resource, we need to use a post mapping annotation to handle HTTP post request. This is URL public void add product. And to tell Spring framework automatically serialize JSON data from the clients into Java object, we use annotation request body here, request body product, and in the methods body we simply call the service method service dot save product. That's it, very simple. And now let's test this RESTful web services API. Stop the application and start again. because this method serves only HTTP post request, so we need to use CURL tool to test CURL here. CURL. And first, we need to specify the HTTP method, which is post, and the header. Specify the content type sent by the client is application JSON content type application /JSON. And use the D option to specify the data sent to the server, which is a JSON representation of a product. The property name of the product name is Kindle, and price property of the products price, for example 189.89, and then the URL HTTP localhost products, and hit enter. Okay, and we can verify by type this command cl localhost 8080 products, and you can see the third product with ID 3 name Kindle price 189.89 appears here, and let's verify in the database. Here you see, now I run this select command, and you can see the third product Kindle and the price here, which means our RESTful web services API for the CRUD operation is working very well. Next, let's implement the fourth method in the REST controller class that exposes a RESTful web services API that allows the clients to update a resource, to update information of a specific product via HTTP put method here. So for this method, we use a put mapping annotation to handle HTTP put method URLs the // product, and followed by the ID of the product need to be updated. Public update product. We need to use request body annotation to tell Spring to serialize, to convert JSON representation of a product to a Java object, to a product object. And we use a path variable annotation to map the value of the ID here to a variable, to a parameter of the method ID. And we simply call service save product. and we should check for the ID of the product to verify that the product has a product exists with this ID. So we get a product exist product based on the ID service get based on ID. If no exception occur, if we save the product, if there's an exception occur, which means no product found, no such element exception, we return HTTP not found status. So this method should return a response entity question mark. And yeah, after the product has been updated successfully, we return a new response entity with HTTP status. Okay. In case of exception, which means there's no product found with a given ID, we return a new HTTP status not found. Okay. And now we can test this method, this RESTful Service API. Run the application again. Okay. And use a CUL tool. Now I want to update the product with ID 1 iPhone X here. So I type this command CUL, specify the HTTP method is boot, and then the header content type is application.json, and then the data, the JSON representation of the product need to be updated. So we need to specify the ID attribute here, ID1, and name of the product is we update to name of the product we update to iPhone 11, and the price is 1000. And finally, the URL of the RESTful Web Service API, localhost 8080 products, and followed by the ID of the product, and V option to see the verbose output. Hit enter. And you can see the server return HTTP 200, which means okay. And let's verify by running this command. And you can see the product ID 1, name updated to iPhone 11, price updated to 1000. Very good, right? And let's check the database. Yeah. Now run the select command again, and you will see iPhone X update. You see, it was updated to iPhone 11 and price is 1000. Now let's test the case that the product ID doesn't exist. So try the command again. Yeah. we specify the ID is 10, which doesn't exist, and URL here ID 10, enter, and you see the server response HTTP status 404 here, which means the resource doesn't exist. And finally, let's implement the last method in Spring REST controller class to uh, provide a RESTful Web Service API that allows the client to delete a resource to remove a product from the database by using HTTP delete method. Go back to Eclipse IDE and we code a new method here. And because this method handles only HTTP delete request, we use a delete mapping annotation and follow by the URL product blocks and ID of the product. Public void delete, and we use a path variable annotation to map the value of the ID here to a variable of the method parameter ID, and we simply call service.delete ID. That's it, very simple. Stop the application and run the event. Okay, let's see in the database. You see we have 3 products here, and now I test deleting the second product Xbox. Okay, using CURL specifies the HTTP method delete and the URL host NTFT products, and I want to delete the product with ID 2. Hit enter. Okay, and we can verify by execute this command. You can see there's now only product ID 1, ID 3. Let's check the database. You see the product ID 2 was removed from the database. And let's try to test delete product ID which doesn't exist. For example, ID 5. You see in the server return HTTP status 500 here, which means internal error. You can see here. No class net.codejava.product entity with ID 5 exists. You can check the existence of the product first, like this, like in the update method here. So you have learned how to develop RESTful Web Services API for CRUD operations on MySQL database using Eclipse IDE with Spring Boot, and as you can see, Spring Boot makes it easy to develop RESTful Web Services API. And as you can see here, we use a REST controller annotation auto-wire with service class, and we use different annotations for different HTTP methods, get, post, put, and delete. I hope you found this tutorial helpful, and thank you for watching, and click the subscribe button below to follow my Java programming channel. Thank you.